Midterm exam review, section C on graphing. I don't expect you to watch the whole video. I expect you to fast forward to answer the questions that you might have, on the ones you're not sure of, or just to check your answers. All right, so here we go. First we have at rest. We need to sketch the graphs for an object at rest on a position versus time graph, and object for rest at a velocity versus time graph. So in a position versus time graph, at rest is a horizontal graph. Okay? Doesn't really matter where it is. The closer it is to the reference point, the closer the object is at rest to the reference point. But horizontal means at rest. In a velocity versus time graph, at rest needs to be on the zero, on the x-axis, because we have a velocity equal to 0. So we have velocity over here. Where it's 0, you're at rest. So that's at rest. Constant positive velocity and a position versus time graph, that's going to be any sort of a positive slope. Okay, so this one's going to start at the reference point and have a positive slope. In a velocity versus time graph, positive constant velocity is horizontal. Constant velocity is horizontal. And because over here is velocity, any of these values going up are all positive. So anywhere along here would be a positive constant velocity. Down here would be slow, medium, fast. Accelerating in the positive direction. So in a position versus time graph, positive direction means it needs to have a positive slope. Not a negative slope, a positive slope. Okay? So some sort of a positive slope to this, accelerating. So to get it, accelerating, we're going to start at rest, and we're going to speed up and go faster and 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 faster. It's curved like so. And if you notice, if you look at this carefully and look at the tangential velocity, tangential lines, anywhere along that, that's always a positive slope. So starting at rest, slow, positive, medium, positive, fast, positive, very fast, positive, super fast, positive. So accelerating in the positive direction. In a velocity versus time graph, accelerating the positive direction means the positive direction means that the velocity is going to be positive. Okay? And accelerating means that the velocity is going to be increasing. So we're going to start at rest, positive acceleration. A constant negative velocity. Okay? So in a position versus time graph, constant velocity, it means it's linear. And it's got to have some sort of a slope. All right? The steeper the slope, the faster it is. This is positive slope. 0, these are all negative slopes. So anything down here is a negative slope, means negative direction. All right? So long as it has a negative slope, it's negative direction, and linear means it's a constant, so a constant negative velocity. In a velocity versus time graph, constant velocity is horizontal. But to make it negative, remember velocity being on our y-axis here, positive velocity, negative velocity, it has to be somewhere in quadrant 2 of the graph, but it needs to be horizontal for a constant velocity in a velocity versus time graph. Decelerating in the positive direction means we're going to start off in a position versus time graph. We're going to start off with a steep positive slope. So positive, steep slope, and then it's going to curve so that it ends up decreasing velocity, and we're going to go down to a 0 at rest. So if you look at these tangential lines, they're always positive velocity. It's just going from fast to a medium positive to a slow positive to a very slow positive to at rest. Okay, so that's decelerating in the positive direction. In a velocity versus time graph, decelerating in the positive direction just means that the velocity is going to have a positive value. All right? But decelerating requires that the velocity is decreasing. So we're starting at a high velocity, and we're going to decrease that velocity down to 0. All right? This section, our velocity versus time graph, analyzing this graph. So watching this graph and seeing what's going on, it asks first, what variable is on the x-axis? Well, if it's a velocity versus time graph, time is always on the x-axis. Variable on the y-axis is therefore going to be velocity. In a velocity versus time graph, what does the slope represent? Okay, well, the velocity, the changing velocity over the changing in time. That is the formula for acceleration. So the slope, which is a change in the y-axis over a change in the x-axis, the slope is going to be equal to the acceleration. Okay? When is the object moving the fastest? Well, over here is velocity, so here's at rest, slow, medium, fast, super fast, super duper fast. So when it's going the fastest is over here, a time interval of 5 to 6 seconds. When is the object at rest? Well, at rest means the velocity has to be 0. The only time that happens is at 3 seconds. Okay? And when is the object moving in the negative direction? Well, all of these velocities over here are all positive. So if the velocities are all positive, then it's never moving in a negative direction. Kind of a trick question there. All right? Now give a full description of the motion and change in motion of the object from 0 to 6 seconds. So, from 0 to 3 seconds, what's happening in a velocity versus time graph? That is in the quadrant 1. Right here we have a velocity that starts at 3 and then goes down to 2 and then 1 and then down to 0. Okay? So the velocity, the object decelerates. Now if I want to kind of compare it over here, like this is that's a very small slope and that's a much steeper slope. So I'm going to say decelerates very slowly. Okay, because the slope tells you the acceleration. Negative slope in the first quadrant means decelerating, and it's just a little bit of slope, so it's happening slowly. So object decelerates very slowly. To rest, because right there it's at rest. Then object accelerates. Right here we have accelerating. The velocity is increasing, going faster and faster and faster and faster and faster. Accelerates faster than it was decelerating. So the object accelerates faster to a, right here we have a constant velocity. Okay, so the object decelerates slowly to rest and then accelerates quickly to a constant velocity. And that's how I would do that section. There's a review on graphing. So just a quick overview of all of the answers there. Do a quick check. There you go.